So number 60, it shows a position time graph depicting Jim's movement up and down the aisles at a store. The origin is at one end of the aisle. Write a story describing Jim's movement at the store that would correspond to the motion represented by the graph. Okay, so what's happening here is it looks like he's pushing his cart down the aisle. He goes 6 meters. He stops. So maybe he stops to look at fruit. And then he continues on down the aisle. And then he stops for a couple seconds. It looks like then he goes backwards. So he's going forwards here and here. Now he goes backwards. So he turns around. I bet he goes back down the other side of the aisle. These are really wide aisles, kind of like at Walmart. So he's going down one side, turns around, goes back the other way. He stops here. And then he's like, oh, crap. You know what? I forgot to get... Oh, geez. I don't know. He forgot to get ice cream. Yes. So he goes back to get ice cream. So he's going backwards from here to here. Stops, gets his ice cream, and then continues back down to the very start of the aisle. Because he's at the same position, so it looks like he went down one aisle. Goes down to the end, stops, comes back. Whoop, got to go back. Stop. Picks it up. Comes back. Part B says, when does Jim have a position of 6 meters? So it looks like he has a position of 6 meters from, this is 10 seconds, so like it looks like, so that's 5, so it looks like from 7 seconds to 24 seconds. So from 7 to 24 seconds, and then over here he's got that same position from like 52 to 56. 52 to 56. And then part C, how much time passes between when Jim enters the aisle and when he gets to a position of 12 meters? Right there. So coming down, so that's 35, so it looks like 32. Yeah, I'd say 32 seconds. What is Jim's average velocity between 37 and 46? So 37 is right here to 46. 37 to 46. So this one's going to be a little bit trickier. His average velocity. So average velocity is just distance over time. So let's figure out how far Jim walked. Well, he went from 12 meters down to 3 meters. So the distance, he goes from 12 down to 3. So that's 9. And the time that it took, well, you can just subtract those. That's final time, 46, minus the initial time, 37. Actually, I should do this backwards because you take the final distance, which is just 3, and then that's 12, so it just becomes a -9. So 46 minus 37, that's 9. Oh, these clever dogs. -1. I would say -1.0 meters per second because these all have 1 to the right of the decimal point. So when I do my subtraction and such, that would be 9.0 over 9.0. So then that gave me 2. So that's part C. -1 meters per second. Yep.